Hi everyone, welcome back to my channel Chemistry Wall by KK. So today's topics mass spectrometry. Okay, so the mass spectrometry consists of the topics: basic principle, instrumentation of mass spectrometry, ionization methods, nitrogen rule, McLeod's rearrangement and factors affecting fragmentations. So let's see one by one. So first, basic principle. So basic principle: mass spectrometry is the most accurate method for determining the molecular mass of the compound and its elemental composition. In this technique, that means in this mass spectrometry, the organic compound is first vaporized and it is bombarded with the beam of high energy electrons. The electrons have 17 electron voltage energy. During this process, the substances loses one electron. Okay, substances lose one electron. Substances loses one electron and forms molecular ion. Okay, during the process, substances loses one electron to form molecular ion. The single electron lost from one of the sigma bonding electrons on the case of alkanes, that is saturated compounds. And one of the non-bonding electrons on the case of one of the non-bonding electrons, that is lone pair F electrons to form the compound containing oxygen and nitrogen. The single electron lost one of the pi electrons from olefins. Okay, and next one of the pi electrons from the higher occupied pi orbitals from aromatic compounds. Okay, the molecular ion carries one unit of positive charge and one unpaired electrons. It is denoted by M plus radical. That means substances lose one electron to form molecular ion. Okay, these molecular ion carried positive charge and one unpaired electron. So these denoted M plus and dot. Okay, we'll see the equation. So M plus E gives rise to M plus radical plus 2E. That means it is a neutral molecule. So it is high energy electrons of 17 electron voltage. So it is molecular ion or radical cation. Radical means, so this is radical cation. So molecular carry positive charge. In this radical cation or molecular ion, so A plus B, okay, it written also A plus and B radical, and also C plus D. It means A plus means even electron ion, and it is the radical. It is odd electron ion and it is neutral molecule. Okay. So next illustration. So we'll take neopentane. So CH3, 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 CH3. High energy electron of 70 electron voltage to form molecular ion CH3, CH3, CH3 plus radical CH3. Okay, plus 2 electrons. It is the molecular ion. Okay. In this, sigma bonding electron removed from neopentane, okay, to form molecular ion. It also written as M plus radical. Okay. So next CH3 OH. So oxygen have lone pair, 17 electron voltage beam to form CH3 bond O bond H plus 2 electrons. In this case, non-bonding electrons, okay, non-bonding electrons removed from the alcohol. The value of M by Z is equal to 72, and the value of this molecular ion M by E is equal to 32. M by E. So next, molecular ion or parentation. So in some organic compounds, molecular ion is appeared with 100%. Okay, in some organic compounds, molecular ion appeared with 100% intensity. Okay. This is known as base peak. In some organic compound, molecular ion has low intensity. In some organic compounds, molecular ion signals is not obtained. So next, characteristics of molecular ion. The given organic compound is converted into vapor. The vapor is bombarded with an electron beam of energy 70 electron voltage. The substances lose one electron to form molecular ion. it may be formed in different ways. Okay, so M electron beam 17 electron voltage to form molecular ion. So in the case of saturated alkanes, one electron lost from C to C sigma bond. So for example, electron beam 17 electron voltage to form molecular ion. Okay, it's also write as C2H6 plus radical. Okay, so next, in the case of compounds containing oxygen and nitrogen, single electron is lost from one of the lone pair. Okay, so oxygen have lone pair and nitrogen have lone pair. So removal of one electrons from lone pair. So example, not OH, so oxygen contain lone pair, electron beam with 17 electron voltage from R, one electron loss. It is a molecular ion, or it also written as ROH radical. Next, in the case of olefin compound, olefinic compounds, single electron is lost from pi bond. Okay, olefinic compounds, single electron lost from pi bond. So example, CH2, CH2. Okay, radical, it's pi bond and sigma bond. So in this olefinic compound, single electron is lost from pi bond. Okay, it is pi bond. Electron beam, 17 electron voltage, CH2, CH2. So pi, one electron removed, so remaining one, and sigma. It is a molecular ion. It's also written as C2H4 plus radical. Next, in the case of aromatic compounds, the single electron is lost from higher occupied pi orbital. Okay, in these olefinic compounds, remove electron from pi bond. In this aromatic compound, remove one electron from higher occupied pi orbitals. So example, aromatic, electron beam, 17 electron voltage to form molecular ion. So the structure is plus. It's also written as C6H6 plus radical. So next we will discuss base peak. Okay, so what is base peak? The highest intense signals noticed in the mass spectrum of a compound is known as base peak. Okay, the highest signals noticed in the mass spectrum of the compound is known as base peak. So for example, if you take any substance, so it is highest intense signal. Okay, so this is known as base peak. Okay, base peak may be due to the molecular ion or fragmented ion. So what is fragmented ion? It's also called as daughter ion. So the M by E value of molecular ion is equal to the molecular weight of the substance. The molecular ion passes high energy and it undergoes further splitting to form fragment ions. So for example, it is a molecular ion. Okay, it's further divided so these are known as fragmented ions or daughter ions. Okay, in fragmented ions carries positive charge, radical or negative charge. Okay, fragmented ion carries positive charge, negative charge and radical. In mass spectrometry detects only positive. Okay, in mass spectrometry only detect positive. It's not detect negative or radical. In the fragmented ions, so it is a primary fragmented ion and it is secondary and it is tertiary fragmented ion. So what is primary fragmented ion? Okay, fragmented ions directly obtained from molecular ion is known as primary fragmented ion. So what is secondary fragmented ion? Fragmented ion obtained from primary fragmented ions is known as secondary fragmented ion. What is tertiary fragmented ion? So fragmented ion is obtained from secondary fragmented ion is known as tertiary fragmented ion. Next, mass spectrum. So mass spectrum is plot of relative abundance versus M by E value of fragmented ions. It is recorded in the increasing order of their M by E value. That is, it is RD, means relative abundance. M by E, it is a value of fragmented ion. It is recorded, so these two both are recorded in the increasing order of their M by E value. So what is RA? Relative abundance. So what is relative abundance? In the ratio of concentration of any individual ion to the total concentration of the ion. Okay, relative abundance is equal to total concentration of ions. Okay, for example, illustration, Neopentane, when bombarded with electron beam, it gives molecular ion. It undergoes fragmentation and gives different fragment ions. So CH3, 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 CH3. The structure of this neopentane. bombarded 17 electron volts beam to form molecular ion CH3 okay, plus radical. It's undergoes the fragmentation. So first C4H9 plus CH3 radical. Okay, so these are okay. Did you understand? So next, the M by E value 57. So next C3H5 plus CH4. M by E value 41. Next C2H5 plus M by E value 29 and C2H3 plus M by E value 27. So it is the diagram of mass spectrum of neopentane. It is the parent or molecular ion, the value 72, the fragmented values, so 57, 41, 29, 27. So 51 the highest, the next 41, 29 and 27. It is a highest signal is known as base peak. Okay. So next, applications of mass spectrum. So it is used to determine the molecular weight and molecular formula. Okay, it is determined by molecular weight and molecular formula of compound. So next, for saturated elucidation of molecule, saturated elucidation and the distinguish different isomers. These are the applications of mass spectrum. So this is today class. Next class we will discuss instrumentation. Did you understand the concept? Like, share and subscribe. Thanks for watching.